So now we've got Igor Savin setting up here. He's a fastify core contributor. He's a principal software engineer at Lokalise, and he's going to be talking to us about advanced caching in Node.js. So, are you ready there, Igor?
I think so.
All right. Give it up for Igor.
All right. I guess I need to switch the display mode. Duplicate. All right, much better. All right. Hello, everyone. Today we're going to talk about caching. You can find me on GitHub and Twitter as KeyboardToad. A little bit about myself. So, I'm a principal software engineer at Lokalise. I am one of the members of the Fastify organization, primarily on the Fastify plugin team. I'm a lead maintainer of knex.js, and I have built a bunch of open source packages over the years. The one that is the most relevant to our today's conversation is a layered loader, as it is a caching engine, and the one that implements pretty much all the functionality that I'm talking about today. So I'll be using it to illustrate the points that I will be making. And overall, today I would say I have two target audiences in mind for what I'm going to be talking about. So first, the ideas that I would like to push forward are primarily aimed at people who are implementing caching solutions or caching libraries, with the hope that at least some of them would be adopted in the libraries that are currently widely used in the ecosystem. Right now, this is not the case. And second, I would also like to speak to people who use caching in production, so that you, A, could either adopt those features when they're more widely available in different packages, or just use a layered loader which already supports them. All right. Here's the agenda for today. I will start by giving a very brief introduction to what caching is, what it is about, what it aims to solve, and how to people who never heard about caching. I assume they exist. Then I will go over the maturity stages of caching and give an overview of the most simple and manual approach of doing that. So the official term for that is cache as hide. Then we will move on to the current state of the art in the ecosystem represented by read-through caches. And then will come the most exciting part of the presentation. We will talk about what we could be doing differently, what new things we could be doing within the caching landscape to improve upon what is currently very widely used. All right, let's dive in. So the first part, caching at a glance. If I had to define what caching is about in one sentence, probably that would be this. Caching is the art of doing work once. Because why would we want to do unnecessary work? And in this case, this work can be many different things. So it can be a database call. So we could be generating unnecessary DB load there. It could be a REST API request somewhere, generating load on the external system. And it could be just some kind of an internal computation, which is expensive, and you do not want to do this often. You do it once, you reuse it. So here you can see a diagram. So I will be using the database example throughout this presentation, because this is by far the most typical areas of application of caching. So here you can see the very simple flow. So we have 3 users, so there are 3 requests coming to our system, and they are requesting some kind of an entity, the same one. So we see the 3 requests come in, we make 3 calls to the database, we return 3 responses. Not very effective. 3 times more effort than is absolutely necessary here. So what can we do? The most typical solution to this problem is the usage of key-value storage, such as Redis. Because Redis is so much faster than traditional RDBMS database. So if you use something like Redis, your speed of retrieval of entity by ID would be in most cases, below 1 millisecond. Much faster. So let's go through the ways how we can make that happen. So the most traditional, old school, naive approach to that is called cache aside. And one example of a popular package in Node.js space which implements this approach is Cache Manager. So the whole idea behind cache aside is that you perform manual handling of your cached data. So flow goes like this. You receive a request for particular data. Then you directly in your code go check the cache. Oh, cache, do I have this data? I don't. OK. Then I myself go to the database. I retrieve the data. I populate the cache. Then I return the response. And then when another request comes and asks for the same data, I will repeat the process. I will already find the data in the cache. And I will return it without going to the database. So great success, problem solved. Thank you for coming to my presentation. It's perfect now. I wish it was that simple. There are nuances, and we're going to talk about them. For instance, if you have a heavy load system with lots of concurrent requests coming at the same time for the same data, what is going to happen is that they will ask for the same data first in the cache. So we will get 6 concurrent requests, for example. One of them will ask cache, do you have the data? No, I don't have the data. The second one of them will ask, do you have the data? No, I don't have the data. All of them, after this check, because it's done pretty much at the same time, will initiate the request to the database. So 6 requests to the cache, 6 requests to the database, 6 times you populate the cache after that. Not great success, not efficient. So how do we avoid this kind of effort duplication in a high-load system? And the answer is read through caches. So probably the most mature solution in the Node.js space, which you definitely should at least give a try if you haven't already, is the async cache dedupe library implemented by one and only Matteo Collina. And the idea behind read through is basically this. Whenever you get a request for data, you do not check the cache directly. You do not populate the cache directly. You do not call the database directly either. All that you do, you come to your cache engine and say, oh, hey, I need this data, and I don't care how you get it. If it's cached, give it to me. If it's not cached, resolve it, cache it, then give it to me. So what happens under the hood in the Node.js variations of the read-through caches is that when there is a call for a particular entity to a cache engine, it will create a promise which eventually will resolve with the entity in question. Then, if someone else asks for the same data while this promise is still hanging, everyone else will get exactly the same promise, which by itself is cached. So 6 requests come to us. Cache engine gives all of them same promise, checks the cache. If it's not there, gets the data from database, populates the cache, resolves the promise. All 6 requests receive the same response within the same promise. Extremely efficient, much better, finally great success. Still not perfect. Now let's take a look at the big guns here. Let's take a look at what is currently not being done in Node.js space, which could make your cache so much faster. Let's take a look. So in order to improve the status quo in Node.js caching, we need to address 2 big topics and one bonus one, which might be relevant in certain cases. I will go into greater details as we go further. So 2 big topics that we need to address is the fact that promises in Node.js, as you're well aware, are quite expensive. And second thing, data can go stale. And you need to address that. Because if cache is serving you the data which is no longer relevant, it starts bringing negative value. So we will take a look at the options that we have there that we could apply to address both of them. And the data refresh latency, the situation is that sometimes the operation that we need to perform in order to resolve data is expensive and takes a long time. So there are ways to alleviate that particular problem. So here I will start talking about the layered loader. So this is a library which I built a while ago and then kept evolving within the Lokalise use cases, which I will talk about later as well. So you can see the URL there. It's free. It's open source. You can use it today. And it offers solutions for all of the three problems there. So it provides you an optional synchronous API for the in-memory cache, which generates 0 promises. It provides you a distributed cache invalidation functionality, meaning that your in-memory cache can be used as your primary caching solution, meaning that you can get the best-in-class performance and perfectly fresh data always. And it implements a refresh ahead pattern, which, again, I will introduce in more details briefly. Let's go through all those cases one by one. So, currently popular caching solutions generally treat the Redis caches and in-memory synchronous caches the same way and expose them via a synchronous API for simplicity, for convenience, for uniformity. However, that conceptually is very similar to how when you're being asked to pass over a spoon or fork over the kitchen table, you take out the cardboard box, you pack the spoon inside of it, you pass the box, they have to unbox the box, then they take it out. It's doable, it's okay-ish, even though you're going to get weird looks, but it's not fast. And I have some numbers to show to you that illustrate the impact of having asynchronous APIs to your in-memory stores. So here you see a table with 3 different caching solutions. So 2 ones on the left are popular caches implementing read-through pattern, so full-blown caching solutions. The one on the right, Toad Cache, is just a simple in-memory least recently used store cache, which doesn't do anything more than that. It's just in-memory cache. And you can see the difference in operations per second between those approaches. So probably just by the numbers themselves, you can guess which ones use promise and which ones do not. But in case you need a hint, yeah, promises, promises, no promises. So the difference is 5 to 8 times, with or without. So what is the solution here? How can we maintain all the universally applicable use cases that caches are generally used for, but still have highly performant caching solution? Let me show you. So what we have implemented in layered loader is optional synchronous API for in-memory. We're treating the in-memory cache not as an afterthought or just alternate implementation of the same thing. We conceptually recognize that it's different and should be handled differently. So you can see the code example here that there are 2 different entry points to your cache. You can explicitly say, oh, hey, layered loader, give me the value that you have in memory cache if you do, and do this synchronously. So this is the first part of the resolution. This executes incredibly fast. And if it's a successful hit, then that's everything that you did. And in case you don't have the value there, you are going to execute the asynchronous path here. So get async only in this particular case will go to the asynchronous cache if you have it configured. It might be Redis, for example. If there is no asynchronous cache being configured on, it doesn't have the value that you're searching for, then it will use the resolver to actually load the data directly from the database or perform computation or whatever is the defined data source for the data that you need. And as you can see from the table, even though this approach is slower than what you see in just very trivial in-memory cache, there is obviously some overhead to more complex functionality that cache engines provide. You still can see that the layered loader approach here is significantly faster than existing solutions. So this is one big takeaway for any people implementing caches who sit in this particular room or are going to watch the recording, If you build a caching solution, please consider exposing synchronous API for in-memory storage if you support one. This is going to be much, much, much faster. So all good and fine. We improved our performance here. But you're going to say to me that that doesn't matter in the end of the day. I still can't use in-memory cache for a majority of my cases because I do care about my data growing stale. I cache it in memory, then some other member of my distributed system invalidates the data, and I still have obsolete data cached in my first node. So in-memory cache is useless. You can only time it to like 5 or 10 seconds and frequently invalidate, so this kind of makes the whole performance boost moot. Well, yes, but actually no. What you can do here, you can apply the distributed in-memory cache invalidation approach. So basically make your nodes talk to each other, as the cats in this picture do. So you can implement any kind of a messaging solution. So in Wired Loader, we used Redis PubSub. Or you could use anything that supports fan-out communication from one node to all other nodes. So whenever any kind of invalidation or deletion command is issued, message is fired to all the nodes, and they invalidate that particular entry in their in-memory cache. So through application of this particular pattern, you can completely remove the Redis cache altogether from your system and just use in-memory cache for everything. You can time it to like hours or days and invalidate it using messaging. How cool is that? So again, strong encouragement to any people who build their own caching solutions. Take a look at what we have done, take a look at sources. You can just copy the whole integration with Redis PubSub if you want. It will be awesome to see it around used more frequently. All right, so the final problem that I would like to talk about is related to potentially long refreshes. Because even if you have the fastest cache in the world and it's perfectly fresh, it's still no good if you take seconds or sometimes minutes to repopulate it after it expires, because that can cause unnecessary latency for your customers, or it can cause your system to overload. So this can be prevented if you apply the pattern called refresh ahead. The whole idea of it is that in addition to doing the checks of TTL for when your data becomes stale and you want to evict it and repopulate again, you have a separate TTL for checking whether we want to start refreshing ahead of time. So the benefit of this is that you still have the data which is fresh and perfectly servable, but in the background, after this second TTL is reached, you asynchronously kick off the whole refresh process. So it finishes before the data ever becomes stale, meaning that your customers will always be getting fresh data and it will always be refreshed ahead of time. But caveat here, while I definitely recommend applying first two patterns in pretty much majority of situations, this one should be used carefully because it does introduce additional overhead of its own. Because obviously checking how long is it still till your entry is going to get expired, since obviously Redis is not going to help you here. It's not going to expire anything by itself. It's just going to return to your metadata. The same with the in-memory caches. You need to keep track of how far along the TTL you are by yourself. So there are additional checks to see whether you need to kick off the refresh ahead thing. So in Wired Loader, we implemented cache inside our cache to make it performant so that we don't constantly trash Redis with those requests. But if you're implementing your own solution, be careful and measure that carefully. So big recommendation here, only use refresh ahead in cases when you know that some of your refresh operations are expensive, take a lot of time, and it's not acceptable for you to refresh them on demand whenever user sees that the data has become stale. All right. So don't get scared. There won't be a quiz on this after. This is just a table to illustrate that all the checkboxes belong to us. So we tried our best to be the most feature-complete solution on the market. We still don't have the book, the application, unfortunately. Hopefully, eventually we will. But yeah, Weird Loader, hopefully some of you will try it. Hopefully you will like it. If not, please send bug requests, complaints, suggestions, whatever. We will improve it. All right. Now I'm going to talk a little bit about the background of using Weird Loader and Lokalise, what we used it for, how we used it, and what was our experience. So as some of you already know, Lokalise is a translation platform. And one of the features that we provide to our customers is basically if you have a mobile app, you can use our SDK for integrating with our platform for serving translations. So whenever a customer opens some application that uses our platform on their mobile phone, they will use the SDK to fetch the translations and cache them on your device so that you have up-to-date translations of your application. This particular API generates thousands of requests per second. So as we were modernizing it and introducing more complex logic, we realized that it started becoming slower than our original implementation, and we needed to speed it up. So, which is why we needed to create a solution which would allow us to absolutely eliminate all the unnecessary work and reuse all the data very aggressively, which is a good fit for this particular scenario because obviously many different customers are going to be requesting translations for the same exact application. So there are lots of overlap and there is a lot of cache hits for same things over and over. So this allowed us to make the solution perform even better than the original implementation before introducing of this whole complex logic. So this is part of the efforts that we undertake in order to ensure high performance within Lokalise because our customers consistently raise up the topic of performance. And we know that they care deeply about it. So we try to build solutions that accommodate for that. Almost the last thing. So I would like to say big thank you to Ronald Brakes, who from the Lokalise, who has offered quite a lot of great ideas and thoughts and a bit of code for the Weird Loader, and to Diana Balzite, who has created the wonderful illustrations that you have seen in this particular presentation. Thank you for your attention.
That was brilliant. Thanks, Igor. And it's so nice to see cats actually making their way into a presentation, even this late in the day. Does anyone have a question for Igor? Oh, here we go. Oh, I'm not sure. Yeah, I'm not going to shuffle all the way in this time. I'll pass the mic down.
Hi, my name is Armin. I'd have a question. You mentioned you use Redis PubSub for cache invalidation. So as far as I know, it doesn't have any delivery guarantees. So how are you dealing with that in a matter of that you could eventually have inconsistent data in some instances if you don't have a delivery guarantee of the PubSub?
Potentially, yes. However, so in majority of cases, the reason why you wouldn't be able to deliver something to one of the nodes is because node is down. After you restart the node anyway, it's going to refresh the data. However, probably in certain cases, that might still be the case that the node is up and it has the data and you don't have durable delivery and something gets missed. That is very fair. So I would say that for those particularly sensitive scenarios, it would make sense to implement a different notification adapter. So this is already perfectly possible. The Weird Loader exposes the interfaces that it uses for publisher and notifier. You can create your own implementation and pass it there. So for this particular case, I would probably then recommend implementing an adapter using either Redis streams or SQS or something along the lines. And if you ever do, please send a PR. We would be very grateful if you contribute this back to us.
Thank you.
All right.
Any more questions? I think they're all a little hungry. Well, thank you again, Igor. And I get to come back up on the stage now.